Okay, and welcome to Statistics Part 2. And we're going to be going a little bit more into what we would call descriptive statistics, which is what researchers in psychology use. And we're going to start with this first subtopic. Well, let's start with the top, the title. You're just going to write, it's going to be descriptive statistics. Okay, will be that, or you could just put stats, whichever you like, but descriptive stats is work. Now, the first subtopic you're going to write is descriptive statistics. And I want you to tell me, well, I'm sorry, not tell me, but I want you to write down after that your little bullet format. What does it mean? So, descriptive statistics is basically how they're going to organize the data with meaning. Okay. Now, they're going to use, next little bullet is they're going to use numerical data, okay, used to measure. That's one. So they're going to have numerical data used to measure. And then the next one is they're going to describe the characteristics of the groups. Okay. And in order to do that, you need to have different ways of measuring. One of them is going to be measures of central tendency. You don't have to write this down because I'll go into it. There's going to be variance, right? How our numbers vary. And I'll show you little tricks of how to remember these things because it is a lot. Okay, and then there's also this frequency, then correlational coefficient and scatter plot. We already did that. So that was part one. And then we'll talk about inferential statistics. Okay, first thing we're going to look at is is frequency distribution. So write that as your next subtopic. Remember to skip a line and then write this down. So it's going to be frequency distribution. Okay, and frequency distribution is basically, and you guys seen this, you've learned since elementary. It's basically showing how frequently, okay, and write this down, each of the various scores show up. Okay, so it's basically how frequent a score shows up in the data. Okay, so for example, here they're going to have, suppose you're collecting data on how many hours of sleep college students get each night. So you might want to write this as an example. So you could just write, the next little bullet will be, sorry, I don't know why this thing does it. It literally just skips, and I'm not touching anything, I promise. Okay, so here they're going to be looking at, they're going to collect data of hours of sleep of college students each night, right? So just write that down, the hours of sleep for college students, okay? So after they conducted, right, the study, they had got a survey of 30 classmates, and you're left with the following data, right? So then they give you all of this. So this is basically how many hours each person slept, right? So here's the numbers, and then basically what a frequency distribution looks like, and I'll show you the next slide. It's not going to be there, of course not. Okay, so what they would do is count how many times these numbers show up, and the way that they graph them, so please make sure to write this. If I am using a frequency distribution, many times what they will use is a histogram. So if you want to write it under frequency or create your own subtopic, you can do that. But please make sure that you're writing this down and learning. So a histogram is like a bar graph. The only difference is that they are touching. Okay, so, and they will have this, and they will have a bar graph, or they'll tell you, please draw a histogram or draw a bar graph. And if you put those bar graphs, let's say they want you to put a bar graph, and you put them together like a histogram, the whole thing is incorrect. Okay, so a histogram is just basically, it just represents a continuous number. Okay, so it's just continuous. There again, there's no spaces in between, and usually we're gonna use this data for interval or ratio scales. Okay, so don't worry too much about when they're being used. It's just if they're telling you to do that, which usually it's just a bar graph is what they ask, but they are not touching each other. Please, if it's a bar graph, it's a histogram. Yes, because histograms show frequency, right? So the continuation of numbers. Now, This is the next subtopic, and it is quite important, and it's called central tendency. Okay, so skip a line and write this. Now, this is how I tell my students how to remember this, okay? So, because it is a little bit complicated and they use this vocab. So, break it down. That's the beauty of psychology. You could break down words if you look at them and you're like, I have no idea what they mean, but here they are. I'm gonna break it down. We're gonna use some common sense. So, central is basically the middle, right? So write this down under your notes that the central is the middle and tendency is basically where it tends to be, right? So tends to land or tends to be is a good one, okay? Some people use other synonyms, whatever works for you. We'll talk about it more in class of what works for you. So this is basically central tendency is that the data tends to be kind of in the middle, okay? Which is basically what this definition says here, which is a scores, right, tend to congregate around this middle variable, which means most of your scores are going to be near this variable, okay? Scores near, or they're going to be near this number, okay? And then here we're going to look at basically the average. So we're looking at the average, the middle is the average, okay? So good way to remember that when you see that. So under central tendency, how do we get these, sorry, there it is again, the middle numbers that they tend to be? And that we do it three ways, okay? So how do we measure the middle numbers, right? And then that is by these three things, and you're gonna need to write that. So how to find it, so write that. How to find, this should be your key, I'm sorry, your subtopic, how to find the measures of central tendency. And the first one is your mean. Okay, and the mean is basically the average of the data. Okay, you'll get one number that is basically the average. How do you do this? And please make sure to write this down. How do you do this is you're going to add up all of the numbers, all of the data, and then divide it by how many you have there. Okay, and then that will give you the average. You count them up. Let's say I have 10, and this is what I do, like to find the average of your test scores and your quiz scores. I collect all of the quiz scores, right? I add them up, divide them by, if I have 30 students, I divide it by 30, and then it'll give me a number, right? Let's say it says 85. 85 will be the score, right? Or sorry, the average that most of my scores will be. So if you are like, if the average is 85 and you got a 90, that means you're above the average, right? So you did better. But I also want to make sure my scores are near that 85. So for the most part, I usually have pretty high numbers that are close to each other from the average. Okay, and I'll talk more about that. And when we look at your quiz scores and your test scores, because there will be that competition between the periods in which you'll be able to see, okay, am I close to the average or not, right? And that's what I look at. When I tell you guys, I look at data of you guys. So let's say I give you guys your unit one test and the average score, right? The average of all of my periods is close to from 85 to 90. Then that means I know that for the most part, most of you guys are performing at an 85 to 90 range, which is great. So I want most of my students to be near that number, right? So if they got an 80, they got a 95, I know that they're doing okay because they're near the mean. However, if I have a student that got like, let's say a 67 or a 70 even, it's not bad, but it's definitely further away from the mean. So then I know I need to really tackle with that student that concept. Also, it sometimes happens that, let's say the test scores, the mean is a 70%. That tells me as a teacher that a lot of students have not mastered, right, that the concept. So I need to make sure to reteach it, throw it in there when I have to do review, right? I tend to then review more that unit. Okay, so it's always good to find these out, not so much stress as you guys like to do with the test. It just lets me know what you're understanding, what you're not. Okay, the next type of measures of center tendency is also going to be the median. So the median is basically the number, the score that is basically kind of in the middle, right? It's in the median. I think of the median as you also call the median in the roads, like the highways, those concrete, walls. That is the median. It's in the middle, splitting. So what it does, it basically splits the upper half of the scores. So make sure to write that down from the lower half of the scores. How do you get, how do you find the median? Okay, two steps. So the first one is you must order them from smallest, from least to greatest. Order from least to greatest, right? And then it's going to be greatest. All right, you get it. Then you're just going to count from each end, right? And just move in till you get to the middle. If there are two middles, right, it's an even amount of data, you're going to get the two numbers you found in the middle. I used to tell when I taught elementary, I was like, put your fingers in each end and kind of jump over till they meet. And then once they do that, if there's two, add it and then divide it by two so you get the average of those two numbers. Okay, so that's how you get median. And then the third one is going to be mode. So mode is basically the score that happens the most, the data, right? So the score that occurs the most often when it comes to your data. Okay, now why do we need to know all these three? Basically, these three are good when we have certain like scores. Okay, so for instance, the mean is great when you have a normal distribution. Okay, a median is good, right, when you have skewed results, and we'll talk a little bit more about that. And then the mode is basically it's good. We use the mode when we have like two, so we could graph it with bimodal graphs, and I'll talk to you guys about that as well. Okay, so I want you to put an example in your notes for mean, median, and mode once you already have that. And let's say you have 6 employees. So I already know I'm going to be comparing 6 individuals. And this is their weekly salary. Okay, so you're going to find, the mean, median, and mode for this. So for the mean, first thing you're going to do is you're going to get all of the numbers, right? All of the salaries. Okay, and then you're going to add them up. You could use a calculator if you like, okay? And then you're gonna add those all up. It'll give you a number, okay? And then you're gonna divide that number by 6 because we have 6 data, right? 6 types of data. So then that will give you your average, okay? Now, to get the median, right? Now let me erase that. Okay, now for the median, I'm going to put these numbers in order from least to greatest. So I would start at 90 and then I go to, my 90 to then 140. And if I have two 140s, I need to put them together. Okay, and I like to just check them off as I'm going just to make sure I didn't miss anything. Then comes 180. Then I get my 200. And then the last one is 220. Then I'll start at the ends of each one, right? And then kind of move in, right? This one moves in two, move in, and then move in, move in. So then I have here, basically, I have two of the same. So I would have to find the average of this, which is 180 plus 140, which will give you right? 320, then you divide that by 2, and so forth, and that will give you the median, which I want you to make sure that you do that to get your median here. Now the mode is just basically, you don't have to organize it by order of least to greatest. You just look which one is repeated. It's the 140, so then you write that down. Do not want to I want you to make sure that you can find that answer. So I will go to the next little slide and you get to check that. So, right, so once I did this, I added it up, divided by 6, I got 161. So we'll just look at this, or 162 if we want to round it off. Then the median is going to be that, get the two numbers in the middle, right? We did that, and your answer should have been 160. And then the mode, here they ordered it, but you don't really need to do that. Just find which one. Now, if there's two modes, then we have a bimodal data, okay? Which here it'll be 140. Now, if you look at these scores, okay, or our central tendency, that means that what this is telling us is that the average, okay, is about 160. And if you look, the mean and the median are close together. So that means that there's not these outliers that are skewing with, or are going to skew your data. Okay. And then the mode, as you see, it's a 140. It's not a great indication of your, what the average is. Okay. Now you got to know how to calculate, which we just did, right? And I'm not going to go over that, but I do want to talk about how the data is distributed. So you may want to write this as a subtopic, the data distributed. And I want you to start with the normal one, right? So the normal curve is basically when your mean, median, and mode are all the same, okay? Which means that the scores are going to land right about here, whatever that may be. Let's say that's 90, okay? And so this is what's called a normal distribution. Okay, so write this first, the normal. There's no skew. That means there's no outliers. Okay, the scores are not going in different directions. So you're going to draw that and just write that this is a normal bell curve. Okay, then the next one I want you to draw is the negatively skewed um, that negatively skewed graph. Sorry, long day. So this is basically where it's going to start from here, right? And then it's going to go up. So this is not, when it looks like this, that means that the mean is here, right? And then your median is closer to the mode, all right? That means that there are higher scores than smaller scores, right? So as a teacher, right, and I'm looking at your grades or your graphs, I want to see more of this, right? More of higher scores than some lower scores, sorry. The outliers are over here. That means they messed up my data, okay? To look like this, that's why it's skewed. Now, when there's a positively skewed, this has nothing to do with good or bad. By the way, it just means where the directions it's going. So very much like positive and negative correlation, that type of mentality, that idea. So with a positively skewed, you have a lot more, I'm sorry, lower scores than the, I'm sorry, the outliers over here. So the outliers got the higher scores, but more people got basically, or the central tendency is here, okay? So which means that your mean, I'm sorry, the mode and the median are above the mean, or below the mean, I'm sorry, they're below the mean. Here they're above the mean. This is just that there are outliers in your data, okay? This what basically it's telling you. So make sure that you have it in your notes here under negatively skewed, this means that there are more high scores, and you need to be able to know this. There's more high scores than and few low, right? And then my lows are kind of my outliers, right? The low. Now, the positively skewed is there's more low scores than, and then few high scores. It's kind of challenging to write with a mouth. Okay, I will master it though. So few high scores, more low scores, right? Would this as a teacher would not want this. Um, and then that's basically it. You need to be able to read that. This means that there is no outliers at all. Okay, they're all pretty much gonna fall within this range or scores. Now, when there is skewed distribution, so still here, and you may want to write this as a subtopic, skewed distribution. When we have something like that, which means we have outliers, right? We have outliers, make sure to write that. We're going to use the median as the measure of central tendency. Okay, so you definitely need to know that. When there are outliers in the data, you're going to use the median as your central tendency, the measure of central tendency you're going to use. You will not use the mean. The mean is only if we have a normal distribution. So make sure to write that you only will use the mean when there is, excuse me, when there is a normal distribution between your data. Okay, normal distribution just meaning that your scores are going to be close to that average. And I know this because my mean, median, and mode are near each other. Okay, if you notice here, this is my mean. I have 70, but then my median and my mode are all the way over here, not even close. And that's because of these guys. These guys kind of messed it up, and these are outliers that are going to affect my data. Oh, okay, outliers. And then because if you notice, this is how most people got the data, or the data landed in this area, then over here. Okay. Now, for the mode is going to be helpful when when there is bimodal distribution. So what I want you to do is just write this down, bimodal distribution, which means there will be two modes we're going to look at because the data lands in kind of both areas. Okay, so it'll look something like this, kind of like two things. That means that there's one mode over here. There's a number here that, let's say it was 50, okay, that it was repeated a number of times. And let's say over here was 80, right? Remember, because mode is how often it's repeated. So let's say there was two, right? Like there's two 80s and two 50s. So you have two. That means you're going to have some that are going to be here. Most of the average is going to be here, as well as over here. That's basically what that means. Okay, but make sure to have this drawn out because they did have a writing that the students had to make a bimodal graph. Okay, so here, in a skewed distribution, what measure of tendency should we use? Sorry, and that would be your median. Remember, when there's a skewed distribution, the median is the best one. This is only good for normal, and mode, we use it when there's more, typically more than one mode. Okay, now we're going to go to the next little subtopic, which is measures of variation. Okay, and the best way to remember this, and because they like to break down these words, or they use these words in the questions, and it's good to just kind of break it down. So measures is what we're doing, right? That's stats of variation. which is basically how my data is going to vary. Okay, more specifically, my average. My average of how it's going to vary amongst the other data scores. Okay, now and exactly like this. It's how the scores vary from each other. That's it. But when you see variation, think of, oh, how are the data varies? And the two ways to do that is through one, the range, and the second one is statistical significance. Okay, and we're about to go write the definition. You could put two types of variations, right? That's what I want you to write as your subtop or like little subtopic of this, which would be two types, and they are range and standard deviation. Okay, the range is basically the difference between the highest and the lowest score. So you'll get, if the highest score is 100 and the lowest score is 50, you'll just get that, subtract it, and you're subtracting. That's why this is the difference. You're going to subtract, and that will give you basically, it'll give you 50, right? That will be your range, 50, which means that the scores are going to be between, they're going to vary between the 50s, okay? It's not a great indication of variation, like how it varies. It's not very specific. So we don't use that one as much. You just need to know what it means and how to get it, right? So if they tell you find the range of these scores, you would have to be able to get the highest number to the lowest, subtract it, and there's your range. Standard deviation is a little bit more complicated. This is your number two. Now, lucky for us, we do not need to figure out the standard deviation, like the calculations. They give it to us, thank goodness, okay, which is basically how much the scores are going to vary from the mean, okay? So its standard deviation is just how much these scores are going to go away from the mean. So if I tell you that the standard deviation is, let's say, a 4, okay, that means that, and write this down, this just means that the scores are going to be 4 points away from the mean. Okay, so they're 4 points away from the mean. So if this is 100, and my standard deviation that they calculated by some way, which we don't need to know about or worry about, is 4, that means that my other main like points are going to be 4 points away, right? So if this is 100, this would be 104, and this would be 108. This one would be 96, and then this would be, excuse me, 92. Okay, so and then you would just have to calculate it down. Okay, now, which it gets a little bit more confusing is the wording of it, and we'll get to that. But just know that this, if they give you a standard deviation of 4, that just means that many of the scores are going to be 4 points away from the mean. Okay, and that's for that. Okay, so range, again, this is how you do it. You get from the largest to the smallest, or I'm sorry, the highest value to the lowest value, subtract it, and this is your range, which basically is meaning that the scores are going to be about 6 points away. Okay? Now, standard deviation is where, and I want you to write this as a subtopic because this is a big deal. Now, it just tells you how spread out the data set is, okay? So if you have a low standard deviation, very important, your second little bullet, low standard deviation means that the values or the data is close to the mean. Okay, so let's say for instance, this is my test, right? And my average was 90, okay? So most students got an average, their mean is 90. And the standard deviation, which is, let's say, 2, right? Which is really good because it's a low number. That means that my other scores are going to be only 2 points away from the mean. So this would be 92, this would be 88, right? 86. So that means that most of my scores are going to land here. Now, how do I know that? And I'll explain this to you guys shortly. Is there's a percentage, especially when there's a normal distribution, and I will tell you that. Okay, now this is a low, right? This is what it looks like. Now, if it's a high standard deviation, write that down as well. That means that the data or the values are further away from the mean. So these are further away from the mean, which is not always great. Okay, so let's say if I have a standard deviation of, let's say, 8 for this, that would be a problem because that means that my next set is 98, and then there's like, which is can't happen because it's more than 100. And then these numbers also will change. That means that most of my scores, I have too big a range that my average scores are landing. Okay, so which is not what I want. Okay, now this is basically a way of getting that, the standard deviation. If you are in stats, you have to learn it, but lucky for you guys, you have a calculator that you can use, and in this class you don't use a calculator, so why it's important. So you need to know about the z-score. This is your next subtopic, and write z-score as subtopic, and it's basically, this is how they measure the distance of one score from the mean. So kind of like what I was talking to you about the SD, the standard deviation. Sometimes the right way would be that they put the z-score, okay? So a positive z-score means that the numbers are above the mean, and then the negative z-score means it's below the mean. Okay, it's basically how many standard deviations there is away from that, and I'll explain that to you shortly. Okay, now if I look here, which one has a larger standard deviation? If I'm looking at these, the difference between these two numbers is basically going to be, the standard deviation is going to be 5, right? As opposed to here, standard deviation is only 1, okay? So obviously this will have a larger standard deviation as this one has a smaller standard deviation, okay? This is the formula, don't need it, thank goodness, okay? So we're going to start with normal distribution. This is a subtopic, and I need you to, you're going to write a couple things as well as draw it, okay? So basically, a normal distribution is where the mean, and write this down, what I'm saying, the mean, the median, and the mode are all the same, okay? That means that your data, your average scores are all very near each other, okay, which we want, okay? Now, we're gonna mostly see this, and this normal distribution, at least for this class, is a lot of the IQ stuff. So when we actually get into IQ, we'll talk a little bit more about this normal distribution, okay? And I need you to draw this in your, in your notebooks, okay? You're gonna draw it, so pause the video, and you're gonna want, best idea is to color code it. Yes, it's a good idea. All right, so this is basically IQ score. So you'll start off with the x-axis, and I'm gonna actually show you guys a way to remember these, the graphs. So this is the x-axis, which we are looking at IQ score. So write that down, and this is basically percentage of the population. Please don't make this small because you're gonna need to know these numbers, okay? Now, this right here, since it is a normal distribution, I look here, this means that the 100 is my mean, okay? So write that down, that the 100 is the mean, all right? Then they're telling me that the standard deviation of 15 accounts for, okay, 68%. But they're telling me that the difference between this score and this one is only 15 points, okay? So for IQ, it will always be 15, okay? 15 standard deviation, the scores. So if I look here, that means that each score is going to be 15, you know, for the 15 apart from each other. Now, when I talk about z-scores, okay, z-scores is basically how many spaces they are away from the mean, okay? So if I tell you there is a +1 z-score, that means that it's going to be up. I'm going up. This is positive. This is negative. You're going to want to write that down. And then it's going to be +1. That means that this is only one step, right, from the mean. My score is going to be somewhere here in the +1 z-score, okay? So the +1 z-scores, the scores will be from 100 through, 115, and write that down. If I put a z-score of -1, right, if this is my mean, I just move over here. So because it's negative, this is going to be 85 to 100. Okay, if I tell you z is -2, that's 2 spots. So that goes 1, 2. And then this would be 70. Oops, my bad. Just erase that. This would be, the scores are 70 through 85. Okay? Because we're only focusing on this. Now, let's get to the percentages. Okay? So if this is my mean, that means that half of the population got these scores and the other half got these scores. But they break it up into percentage. You need to know the percentage. Okay, so for this one, I hope you have a line here. I want you to write in this graph, I want you to write 34%, and it's here. Okay, so this little section here is 34%. That means that 34% of the population received a score of 85 to 100. Okay, so like here, I could tell you that 34% are going to get this score because again, from 100 to 115 is 34%. Okay, which is one z-score, right? Positive or negative. Now, excuse me. Now, if I combine them both, I add them up and it's basically 68%. So if I ask you what is the score that 68% of the population receives, and you would go from here, 85, all the way to 115. And we'll do some practice in class as well. Okay, now if they tell me 34%, or they tell me how many are in this +1 z-score, 34%. Okay, both combined positive, or they just tell you one, then it'll be 68. Okay, so if there's -2, now look, as we get further away, right, from the mean, these percentages get smaller because less people, right, these are most of the scores are in this area, this range, and then the further we get, the less that's going to be because it's a normal bell curve. So here it will be 14%, so make sure you have that 14, and on the other side equally the same, okay? And if I combine these two, right, from 1 and 2, this is 95% of the population. So 95% of the population, their IQ runs from 70, right, because it's 2, through 130, okay? So doing pretty good, 95%. And then we get even smaller, right? So the further we are, the z-score, then the smaller the number, chances of people getting that. The next one is going to be 2%. 2%, This is what's called a low, below average. Okay? And then this is where you start with the different intellectual disabilities. You start here your people with learning disabilities as well as intellectual disabilities, okay? And then a very small percent have below 55 IQ. Now, if we go to the other side over here, we start same concept. There's only 2% from 130 and on, it's considered gifted. Okay, so if you notice, there is two polar opposites. You have on one side gifted here, and this would be the z-score of +3, right? Z-score of +3. And then here, what would be considered an intellectual disability, the Z-score is a -3. Okay, this would be -4, which is a really small percentage. And then this would also be a +4 Z-score. Okay, and these are extremes with scores. This is just another way of looking at it. If you look here, these are the z-scores that you can see at the bottom. But the way that we say it is where it gets complicated. Because this technically, if I tell you how many standard deviations is, let's say, 85 from the mean, and the answer is 1 because it's in the 1 z-score, basically. Okay, so this is where it gets a little bit complicated. Let me see if there's a better graph for that. Let me see. So if you look here, if I tell you what percentage score below the mean, so this is the mean, and it's basically everybody on this side, and if I calculate that, it's 50%. Okay, and then this side is 50% get above the mean. This is above, this is below. Okay. Now, if I look here, if it says what percentage of score between 85 and 100, this would be our answer, 34%. Okay. Now here, from 85 to 115, if you look back here, we're getting from here to here, right? And that would be, you're going to combine them both, and that's basically 68%. Okay. So we also have what's called percentile. And I know you guys have seen this with SATs and your other FCAT stuff or FSA. So percentile. So a percentile is basically means where you are in the group, okay, what you're comparing yourself to. So if you get, let's say, 80%, right, 80th percentile, that means that 80% of the people that took this are below you, okay? So they are below you or got a score lower than you. In this case, they're looking at the height. So if you're the fourth, right, because you're in the 80th percentile, that means that there are, in this case, there are 4 people taller than you, but everybody else, there's 80% that are below you. So if you get a percentile in your SAT of 80%, I'm sorry, let's use another one, like 75%. That means, or 75 percentile, that means that 75% of the people got below your score, okay? But that then also means that 20% of the group was above you. Okay, so make sure that you know how to read that. And because it's not you got 80%, you got a percentile, which means 80% of the people your age or your group got below you. Okay, so make sure that you understand. All right. Okay, and then the last part is what's called inferential statistics. Okay, this is basically where they're going to describe the data And then it's going to basically say, did it test and prove my hypothesis correct or not? All right, and there's different ways of doing that, and luckily we don't need to know super specifics. But once we get this data, right, and they did all those things about the mean, median, and mode, then they're going to have what's called the t-test, okay, which is basically, and you don't need to know this per se, but just in case, you never know, okay, but it's basically when they want to test the data to make sure that it is, right, the cause and effect, so that there's no mistake in this. From this testing, this t-test, you get what's called, and I'm going to show you, hold on a second. From this t-test, they give you what's basically what's called the, excuse me, hold on, trying to find it, statistical significance. That's what's going to determine that. And there's mathematical ways of getting the t-test, but we want to know, is it statistically significant? Which means, is this data, you're telling me the cause and effect, it's really due to the manipulation of the variables, and it's not due to chance. Okay, so I'll go over that, but I just wanted you to know like how we get the statistical significance. It's basically to see if I run this test again and my data, am I going to be consistently getting the same results? Okay, and this t-test basically gives you, okay, now I want to look at that, it's going to confuse all of you. See, like this is a formula, and this formula basically tells you their statistical significance. They'll give you a number. Okay, and that's really what you need to know, which is, write this down, and they've been asking this all the time lately. Okay, and last FRQ last year, they basically used p-value. Okay, and luckily many of my students they didn't remember p-value, but they knew there had to be something with the statistical significance because I drilled it. So statistical significance is, can you basically apply this data, these findings, to the larger population? Okay, so can I come or use these findings with the larger population? Which means if I administer this test again, I am going to get the same results no matter what. Okay, now there is what's called the p-value, which is the same thing as statistical significance. Okay, and your goal is always 0.05 or less. Okay, so we get this number from the t-test thing. We're going to get this, and we want it to be less than 0.05. Okay, which basically means, what does this mean and what do you need to know? Which is this. And this is the answer you're going to put all the time, which is basically that this means 5% of the results are due to chance. So I'll say it again. 5% of the results is due to chance. There's a possibility, likely, the results are due to chance. Now, if I have a p-value of 0.03, that is telling me that 3% is likely the results are due to chance. There's 3% chance that the results are due to chance. Okay, now we do not want higher than this, because that's basically telling me that there's a higher chance that it's not due to chance. Okay, so you could also say, and I want you to write this down, please, because there's different ways of saying it. And the next one, another way of saying it is that the results, so when they ask you, is it statistically significant? And you would say the results are statistically significant. Should speed this up now. The results are statistically, which means the results are due to the manipulation of the independent variable. and not due to chance. This is the perfect answer for any FRQ. This is what you want to answer. If they're talking about statistical significance, this is your go-to answer. Okay?